Okay, and we will no longer write the limit. And let's see what happens. If x goes to 0, on the top, what happens to 1 if x goes to 0? It's still 1, right? It's a constant. It doesn't change. And then on the bottom, I just replace that with 0. That becomes like 1. Square root of 1 is 1. So you just get 1 plus 1, which is 2. So you get 1/2. So the limit of this function is 1/2. Now would be a good time for questions if you have one. We started off 0 over 0. Saw that we had square roots. Tried a conjugate, right? It seems like it worked. Yes? So now you know that. The conjugate is there as a tool. Let's verify this with the graph of that. So when I type in this function, what is it that I should be verifying? When I look at the graph, I should be seeing what? Yeah, as I look at the function at x equals 0, it should look like from the left and from the right, my function should be approaching 1/2. Yes? So I'm actually going to cheat a little bit. I'm going to go here. I'm going to go like this. I'm going to zoom in real big here. Right here, when I'm done, at 0, it's undefined. But as I come in from both sides, it should be approaching that open hole. So let's just check that it works. So we have here, let's see, square root, was it x plus 1?
Yes.
Okay, and then all that minus 1. And then, this thing is smarter than me. Okay, x plus 1. All right, and then minus 1. And then all that divided by x, right? There it is. Does what it's supposed to, right? So technically there's a hole here, right? But we still found the limit. So what we're doing today is give you the function algebraically, finding the limit without the picture, and then verifying with the picture. Yeah? It's hard to see this. This is limit x approaches 2 of 1 over x squared minus 1/4 over x minus 2. So let's just check first what happens if we just try and replace x with 2 right now. So what would we get if we just replace the x's with 2's? 1/4 minus 1/4 over 2 minus 2, right? So x is going 2, that's 2 squared, so 1/4 minus 1/4 over 2 minus 2. This is 0 over 0 again, right? Okay, so whenever we see 0 over 0 from here on out, we understand that this means we've got to do something, right? We do some algebra. There are going to be a few of you on your first quiz over this or the first test that are going to tell me that that's undefined, or you're going to tell me that that's 0 or something like that. And what does that tell me? You really don't understand this, right? I mean, this is the reason we're here is to be able to go after this, right? Not to get to this point and be like, oh, that's 0, or oh, that's undefined. No, no, no. It's about trying to get an answer that makes sense out of this. All right, so now it's time for some algebra or some trick. I don't think we've done a trick yet. We've just done algebra. I guess the conjugate was kind of tricky, yeah? Maybe a little bit, but it was still just some algebra. Wrote down limit, x approaches 2, right? Everything's nice. And okay, so what sort of algebra should we do here? You feel like we should get a common denominator? Yeah, so what we have here is what we call a complex fraction. It's fractions within fraction, right? So whenever we see fractions within fractions, what we can try and do is rewrite it as just a single rational expression, single fraction. So we'll combine these two together. To combine those, I need what? Common denominators. So I'll have to multiply, let's see, the top here, or this one right here by 4 over 4, right? And this one over here by x squared over x squared. And if I do that, then I can get, let's see, limit x approaches 2. All right, what will that next line here read? 4. So we're going to multiply, it's going to be 4 over 4x squared minus x squared over 4x squared, right? And when I put those together, I should get 4 minus x squared over 4x squared over x minus 2. Now, I had this discussion with one of your classmates the other day about division bars. Do you see how big that division bar is above the x minus 2? That is very important, all right? I'll give you an illustration of what I mean by that. Side topic here. 8 divided by 4 divided by 2. What's the answer to that? You don't know. You don't know the answer to that. Which one do you do first? Do you do 8 divided by 4 or you do 4 divided by 2? Which one do you do first? Because if you do that first, you get what? What do you get there? 2, and then divided by 2, you get 1, right? But what if you do that first? You get 2, and then 8 divided by 2 is 4. So this is terrible notation. In order for me to ask you to do this, I have to make one of these division bars bigger. And that tells you which one goes first. So that goes first. That's what that means. Understand? So this division bar being bigger is important. It's saying that this is on top of this, right? It's not saying that this is on top of that fraction. You'll see the difference between those two? Sure? All right, so now what? I mean, I did what someone told me to do. I combined those together. Now what? Multiply by the reciprocal. So you're wanting to multiply by the reciprocal of what? Okay, so yeah, let's go back to this for a second. 8 over 4 over 2 is really the same as 8 over 2 over 2 over 1, right? Yes. And then this is division of two fractions, which flips up, and this becomes 1/2 like that, right? Yes. Okay, we're going to do the exact same thing here, except we're going to look at that as being over 1, and then we're going to flip and go up. All right, so this is all algebra, isn't it? Yes?
Would you simplify the 8 4 first, or 8 over 4?
Here, yeah, this is just to illustrate the mechanics of what's happening. Okay, this is just to mechanically show you what I'm doing here. Okay, so y'all see I'm going to do that? And I'm doing that because I've been told to do that. And that is a legal algebraic maneuver, right? Okay, let's see where this takes us. So we have limit, right? Still have a limit. I have 4 minus x squared over 4x squared, and then I'm multiplying that now by 1 over x minus 2. All right, I'm still just following orders up here. I've done what you've requested. Now what?
4 minus x squared.
This is a difference of squares, right? It is.
So if you factor that, it should cancel that.
Yeah, if I factor this, I think it might help get rid of this, right? Yep. So I haven't pointed this out too much, but maybe now I'll start illustrating it a little bit here more. In the very beginning, we had 0 over 0, right? The biggest problem to this expression is this right here. If that was, let's say that was 0 over 3, would we have a problem? No, because 0 over 3 would be 0. The big problem here is this division by 0. So the part that's causing the division by 0 is this piece right here, right? That's the problematic piece of the expression. And here it is still, right? That's problematic. Over here, this is still where we get division by 0, right? If we try and let x be 2, that's going to be division by 0. So if we could ever get it to cancel out, that'd be great, wouldn't it? And that's why this factoring here should help us, right? So let's factor that, because it's not going to work, directly, but we should be able to massage it properly. Okay, so this, what is 4 minus x squared factor to be? It's 2 plus x, 2 minus x, right? That's the correct factorization all over 4x squared times 1 over x minus 2. Okay, can you cancel? Not yet. They're not the same, are they? So this is 2 minus x, this is x minus 2. So again, we ran into this issue where you pull a negative 1 out, right? You can pull it out on one or the other. If you pull it out on both, then they're both going to change, so they'll still look different. Oh, are you saying do you or should you?
Should you pull it out? Both the equations look different.
Just one of them. I'm trying to think of how I can explain this. Maybe this will help. So let's say I just have two numbers being multiplied together, like that. Could I rewrite this as 3 times negative 1 times negative 5? Right? So I don't need to mess with this one. I could say negative 1 times negative 3 times negative 1 times negative 5. That is also this, right? So when I just want this to cancel out, so I'm going to mess with this one. So I'm pull the negative just out of this one and just ignore that one. Does that help? Yeah? Okay. So let's pull the negative here. Okay. Or you could do it here. It's up to you. Still writing the limit, right? Now when I pull the negative out, I'm pulling it out of this one. And I'm taking the negative and sliding it out to the front. And then I'm leaving this one alone. And then what does this one become when I pull the negative out? X minus 2. Or negative 2 plus x, however you want to write it. But I'm going to write it the way I want it to look, which is that. All over the 4x squared. And then watch this. I'm just going to put them all together. So I've been keeping this one off to the side, haven't I? But on the next line, I just push this one underneath here so it's all one fraction. And now they're gone. I can do that so long as x is not 2. But I'm working in a limit, so I'm okay with that's okay to do that. One more line, and then we'll have an answer. Still write the limit. On top I have negative, and then the quantity in parentheses 2 plus x, and then on the bottom we have 4x squared. And that is it. That is the one we will plug x into, and we will not write the limit anymore. All right, so we get 4, negative 4 over 2 squared, 4 times 4, 16. Negative 1/4. There it is. Negative 1/4. So if I were to be able to graph this function, right? If I could graph it, then as you approach 2 from both sides, the function would be approaching negative 1/4. I'm not going to graph this one. Can we take that on faith? All right, so what do y'all think of the algebra so far? Does everything seem okay? Really what this is going to come down to is your comfort level with algebra. And when you go to do your homework problems, trying something and maybe it's not working out and the algebra gets messy and you just got to keep grinding away. Seems warm in here, no? Kind of stuffy. All right, let's take a look at that one. So we've switched up. We're no longer using x's. See, we're using t's. Limit, t goes to 4, and the expression has t in it. Okay, so that's a dummy variable. It could be x, it could be t, it could be s, it could be r, it could be any letter you want, all right? So this is just to give you some variety. So what is the limit as t goes to 4 of 4t minus t squared over 2 minus root t? So let's do what we've been doing. Let's just try and plug 4 in, see if we get a problem. So what do we get on top? 4 times 4, 16 minus 16 again. So we get 0. At this point, are we saying, okay, we're going to need to go do something? No, it's not at this point. It's we need that denominator to be 0 also. So 2 minus root 4, that's 2 minus 2, 0. So now we've got a situation where we're gonna do something, right? Now, in past classes, I've always said, and you might notice this if you watch the homework videos for this, in my past classes, I've always said that when you get to this situation, this is bad, okay? This is bad. We don't ever want to see 0 over 0, okay? This is a bad situation. So we got to go do some algebra. So if you're watching the homework, you're like, what's he talking about bad for? Now you all understand, okay? So, wow. Okay, so let's take a look at this one. Limit t goes to 4. 4t minus t squared over 2 minus root t. So remember how I told you I'm not going to use the clickers? Right, so I told the person in the math department about that. And then they came and picked up the clickers. They didn't even tell me they were coming to get them. They came and got them from my office. And guess what was in the box? Your little sticks. So I got to go get your sticks from the department later on today. Let's see here. We'll start from the bottom, work up this time. Michael? Michael Z? Right? Okay. I'm just curious if you have any sort of idea of how you... Well, you know what? You got the other one, the conjugate. So we'll move on. How about James Wallace?
Yes.
Okay. Any ideas on how you might want to approach this? You can factor a t out of the top. Okay. Does everyone agree that's legal?
Yes.
Okay. So if it's legal, we'll do it. All right? We can. Well, if it's legal, we'll try it. Just because it's legal doesn't mean you need to do it, but all right, I'm okay with that, James. So I'll let you off the hook there. Yosef? Yes? I'm going for whatever suggestions. This one might be hard to see. It was Yosef right here?
Yeah.
Okay, I heard your voice. I don't know names and faces. Let me ask you, where's the problem at? Like, what is giving us the issue? Like, what is causing the major issue? This going to 4, it's the division by 0, right? So we would love for this to go away, right? So we got to figure out, is there a way to make that go away? If you don't see it right away, it's okay. No? Okay.
Can you just rationalize? I mean, it is a root.
There is a root. You could rationalize. You could try. Is it legal to multiply top and bottom by the conjugate? Sure. We could do that.
Well, it feels like if you square the denominator, it should cancel out the 4 minus t.
If you square the denominator, then it might cancel that out. So I'm glad you brought this up. So one of the things that students like to do with limits is exactly that. They'll say, well, what if I square the top and bottom? Because we couldn't just square the bottom, right? We'd have to square the top. Or can we? Like if someone gives you an expression, like let's say I give you the expression 1/3. Can you just square the top and bottom? I mean, you can, but do you have the same thing? No, you square top and bottom, you now have 1/9. These aren't the same thing anymore, right? So if you're looking at an expression, you cannot square the top and bottom and still have the same expression. The only thing you could ever do with squaring would be to square both sides of an equation, but you don't have an equation here. You have more of an expression. So even though algebraically it looks like that might help, legally we can't do it. And then the other thing on top of that is even if we squared the bottom, let's just say we did, it would not exactly be that top, right? It would be a little bit off. So, okay. All right, so I've heard conjugate, maybe squaring, but now we all see, okay, we can't do that. Anything else? All right, I'm going with conjugate then. Let's go with conjugate. All right? There's a faster way, but let's do conjugate, and I'll show you the faster way after. Okay? So times, what is the conjugate that you want me to multiply by? 2 plus root t. You must do that on the top and bottom. Now what we're hoping for is that when we multiply these together, what cancels? This 2 minus root t. We really want it to go away, right? Somehow? Okay, let's just do it. Man, I really don't feel like multiplying that top out. Let me tell you why I don't want to do this. Because the whole reason the conjugate's here is because this times this becomes nice, right? It's this one times this one that becomes nice. In the previous problem, it was in the numerator, but now it's in the denominator. So let's just rewrite this. Let's leave the numerator completely alone and just figure out what the denominator becomes. And maybe we'll get lucky, all right? We are going to get lucky, but it's not luck. I mean, the conjugate, that was an attack that was chosen for the problem, and okay, that's the top. I'm not touching it. The bottom becomes 2 times 2 is 4. What about the middle terms? They're gone. So all you have to worry about the two n ones. So 2 times 2 is 4, and then it'll be minus, because it's a minus and a plus, it'll be minus root t times root t is just t. So 4 minus t, and oh my goodness, do y'all see that? Look at that. Isn't that nice? This factor and that factor are now going to cancel out, reduce. So long as t is not 4. But it's a limit, so we're safe. See that? Now, we're still maybe not out of the woods. I mean, we should be out of the woods, but let's just rewrite it. Oh, we don't have anything left on the bottom, do we? Okay, so just t, and then I'm going to go 2 plus root t, like that. And now, at this point, I can dump the limit as long as I can plug 4 in for t, which it does go, right? This becomes 4 times 2 plus root 4. So that's going to be 2 plus 2 is 4 times 4 is 16. Questions?
Is there a faster way, or?
I think it's a little faster, but I can show it to you. Yes.
Faster way, because on the first day you like broke down something.
Yeah, exactly. Yep.
She factored the t.
Yep, that's exactly it. So let me go back to this stage right here before we came in with the conjugate. This one I think requires, it's kind of like now that you've done this problem, you kind of see what's going to happen. You can see that this right here, this expression right there, can be factored as a difference of squares. It can be factored as 2 plus root t times 2 minus root t. So that was first day or so I talked about something like this, where, you know, this doesn't look like the algebra you did in algebra, but it truly is okay. This is still algebra. Y'all see it? 4 middle terms cancel minus t. So if you do that as your first step, right, then those are gone. And then you'll still get 16. A little faster? Yeah. But the conjugate is definitely a tool. I mean, we use it. It's very helpful. All right. Let's see. We got a few more, right? Limit h approaches 0. This time we're using h. H approaches 0. X plus h, that quantity cubed, minus x cubed all over h. All right, so let's just check first. What happens when x goes to 0? No, when what goes to 0? When h goes to 0. So what happens when h goes to 0 here? X plus 0 is still x, right? X cubed minus x cubed all over. If h is 0, then that's 0. So aren't we still getting 0 over 0? We still get 0 over 0. All right. So you got to do some algebra. Limit h goes to 0. X plus h cubed minus x cubed over h. What is it that is causing the problem here? The h in the bottom. So it'd be really nice if at some point an h canceled, right? This looks like a difference quotient, doesn't it? You should recognize that as a difference quotient. Yeah. So if you were doing this as a difference quotient, you would just do what at this stage? Just multiply that out, right? You just do x plus h cubed, right? So how do we do x plus h cubed? Let me do that on the side. It's going to be some scratch work. What's x plus h cubed? Does anyone know what it is without like actually doing it? Does anyone have it memorized? How about this one? Does anyone have this one memorized? If it's squared. X squared plus 2xh plus h squared. Okay. So this one is x cubed plus, no, 3x squared h plus 3xh squared plus h cubed. That's that one. I'm not asking you to memorize it, okay? I'm just wondering if anyone had it memorized. Because a lot of students have done this one so much that they've kind of burned it into their brains. We all understand what we have to do here though, right? You know, x plus h times x plus h. And then this one you do that answer times x plus h again and do all that expansion, yeah? Okay, we're going to come back to this. Let's finish this off. This is limit h goes to 0. This right here gets replaced with all of that, x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed. Where'd that minus x cubed come from at the end there? That one, right? Okay, so this was this part from here to here is that, and then this piece is there, and then you see what happens? We get the x cubed here at the back to cancel with the x cubed at the front. And what's good about that those x cubes cancel? Everything that's left has an h in it, right? Everything that's left has an h. So because everything has an h, I can factor an h out of here, here, and here. So when I do that, I get h pulled out, 3x squared plus 3xh plus h squared all over h. So that's me pulling an h out of each of the terms that were left. The h is canceled. That's all difference quotient. You've done that before. It's this last step that makes it calculus. And that is the limit. We're going to do limit as h goes to 0 of 3x squared plus 3xh plus h squared. What is that limit when you let when you let h be 0? If that's 0, that's gone. That's gone. All you're left with is 3x squared. Which means that this is the first example I've done where our answer is not a number, right? Our answer is actually some algebraic expression. And this will all have meaning to us later, okay? For now, just want to show you that you can have a limit where you still get 0 over 0. You run through some algebra, and at the end, you get an answer that's still symbolic, right? All right, back to this, though. I wanted to talk about this briefly. So this one, some people knew. We all know how to do it. This one would be tedious, right? But I'm assuming everyone in here could do this, given enough time. They could grind that out by hand. So how about this one? Does anyone know what x plus h to the 4th would be? No?
That times x.
Yeah, it's this times x plus h, right? Which would, of course, be x to the 4th plus 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the 4th. Of course, right? Of course. Let's do one more. So what would x plus h to the 5th be? I'm going to use this in a few classes, all right? I'm actually going to refer back to this. So that would be this one times x plus h again, right? Which, of course, would be x to the 5th plus 5x to the 4th h plus 10x to the 3rd h squared, right? Of course, 10 plus another 10x squared h cubed plus 5 xh to the fourth plus h to the fifth. So that's what that one is. So do I really have all these like programmed into my brain? Or is there a pattern here? There's a pattern. Okay, there's a pattern. So I'm going to show you the pattern. So some of you may have heard of this, some of you may have not. It's called Pascal's triangle. Anyone heard of this? So Pascal's triangle works like this. You start out, you're going to start drawing a triangle of numbers. And you're going to have different rows, okay? And so every time you move down a row, you have to add one more number to your row. And the rule is that your ends must always be ones. Okay, so let me show you the triangle. 1 is the top of the triangle, all right? The next row has to have 2 numbers, and the ends have to be ones. So 1, 1, okay? The next row has to have how many numbers? 3 numbers, and the ends have to be ones. Okay, so the question is, how do we get the middle number? Well, we do. Well, let me not show it to you. Let me not tell you where it comes from. Let me put it here first. 2, okay? Now the next row has to have how many numbers? 4, and the ends have to be ones. So 1, 1. Let me show you what the numbers are. 3 and 3.
It's the addition of the 2 ones above.
Exactly. So I'll do one more. 1, 1, 4, 6, 4. Those are the numbers. So do you see where they're coming from? This 2 comes from adding 1 and 1 together. This 3 comes from adding the 1 and the 2. This 3 comes from adding the 2 and the 1. This 4 comes from the 1 and the 3. 6 comes from 3 and 3. 4 comes from 3 and 1. Do you all see that? What would my next row be? 1, 5, 10, 10, 5, 1. Y'all see it? This is called Pascal's triangle. So back over here, I need to add one more thing to this. I'm going to go up. This was x plus h to the fifth, right? To the fourth, to the third, squared. How about x plus h to the first power? And then above that, how about x plus h to the 0 power? Okay, what would x plus h to the first power be? X plus h, what would x plus h to the 0 power be? 1. Okay, let's see. Do y'all see Pascal's triangle over here? You have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, right? Yes? And so that's the numbers, but what about the actual letters, the variables? Do y'all see the pattern?
They all have to add to the highest exponent.
Yeah, so whatever the power is, that's this, right? X to the fourth starts with x to the fourth. And then look at what happens as you go from left to right. What happens to the powers on the x's? They go down, right? What happens to the powers on the h's? They come up. You all see that? Okay, so let's try this. What would x plus h to the 6th power be? Let's do just the letters first. Just the letters first. I'll have x to what power? 6th. Plus, now I'm going to have a number here. X to what power? 5. What about h? H now appears. Plus a number. X to the 4th h squared. Plus number. X to the 3rd h cubed. Plus number. X squared h to the 4th. Plus, I'm running out of room, number, x, h to the 5th, plus number, h to the 6th. And now to fill in the numbers, I can go off of this thing right here, right? So my next row would be 1, I don't need it, 6, 15, 20, 15, 6, 1. And so you can continue to build out your, these are called polynomial expansions. Yeah. So Pascal was a mathematician. He gets credit for this, but actually the Chinese had it way before him. It's a nice, convenient way to show off to your friends. If you ever, when your friends are all sitting there, expanding binomials and stuff, you can just kind of impress them with taking it way far. We will use this, like I said, in a few classes because I'm going to prove something to you, and I'm going to need you to go back to this and remember there's a pattern to this, and hopefully from that you'll be able to swallow what I'm feeding you, okay? All right, we need to do another example. How are we doing on time? Whoa, really? Whoa. Wow, I can't believe how much time's gone by. Okay, I'm going to pass this around. If you have a dot next to your name, don't worry about you. Everyone else, make sure you sign in. We're not done. We're going to do this example. The drawback to that, Pascal, is that if you wanted to know what x plus h, let's say, to the 20th power is, you could take care of the powers, right? Like this would be x to the 20th, next one would be x to the 19th h, then x to the 18th x. But to get those numbers, you would actually have to draw your triangle out all the way down, wouldn't you? Well, there's a shorter way. There's a way to get those numbers, those coefficients, with a formula. But it involves factorials, and you get introduced to it in probability and statistics courses, but we're not getting into it, all right? All right. Do we have a problem here? Well, the top's 0, right? We can all agree with that. The top is 0. The bottom is 4 squared, 16, right? Plus 9 is 25. What's root 25? 5. 5 minus 5? So what do you think we should pull out here to do this one? Like what technique?
Well, isn't the stuff in the radical, can't that break down into radical x squared plus 1?
Wait, plus what?
Radical 9.
Like into 2?
Yeah, the 2 different.
If there was multiplication, we could, right? Because it's addition, we can't do the root of each one. Yeah. Sorry? Oh, okay, so no, this right here, everyone, look, just to make sure we're all on the same page, this is not right. So look, when I was in algebra, right, when I was a student in algebra, anytime I did something like that and I wasn't sure, I would just plug a number in and see if it worked. If it didn't work, then I messed up my algebra, right? So if I was like just unsure, can I do that? Everyone understand what I did? Okay, it's not legal, but let's just verify it's not legal. Well, let's just see here. Let's plug in 1. Okay, what would happen if I plug 1 in here? What would I get on this side? Square root of 10. Okay, is that equal to what you get when you plug in 1 here? No, it's not 4, right? Something is wrong, which means this I couldn't do, all right? So you can't simplify this. So what else do we have? We've been using it. Conjugate. Let's do the conjugate again. What's my conjugate? 5 plus square root of x squared plus 9. 5 minus square root of x squared plus 9, right? I'll let you finish that one yourself because we're out of time. All right? No, I'm not going to collect it or anything, but if you multiply that out, I would leave the numerator alone. Put these together, lots of things are going to cancel, and you should get something to go away, all right? So that conjugate is pretty helpful, isn't it? We've used it on several problems. Okay. So for your homework tonight, what I would like for you to do is just the first part of the homework, because we haven't talked about the second part yet. So I believe for your homework, don't do anything past number 28. All right, nothing past number 28. So I would say this, like I know last time is when we started calculus, But like right now, from this point, like you absolutely have to be doing your homework at this point, all right? Get in there, get your hands dirty. You know, you should have like pencil marks all over your hands and stuff, all right? Getting cramps in your hands. All right. Don't go past 28. What's on there for 1.4? Yep. Stop at 28 for one. This is for 1.4. Stop at 28. We'll do the rest next class. Yes.
That is 5 plus 2.
Yeah. Oh, oops. This is a plus. My bad. Plus right there. I put it on the top, but I didn't put it on the bottom. Yeah. Thank you. No, I'm glad you did that. Okay. I can't believe we're out of time. That went really fast for me. I don't know about you.